Started. I am definitely going to go over section 4.3 for certain. So if you have any specific questions from there, you can ask, or anything else from chapter 4.
I have a question of 100.
Let me see. Number 100. Is that the one about the earthquakes?
Yeah.
Okay.
I don't think I did this right.
All right. So this might be a decent one to get us going with this. So what part are you having trouble with?
I think part D, because I don't think I did it correctly.
All right. So let's summarize what we can from this. Can somebody tell me what's N in this problem?
11.
11. I like it. And what's P?
0.30.
So what's Q?
0.70.
I like it. Why did I write it there? I need more space. All right, let me write it over here. N is 11, P is 0.3, Q is 0.7. P and Q always have to add up to be 1, so make sure that's true. And they want to know at least 8. So one thing I want to really make sure you guys should be used to this. I know the book sometimes focuses too much on calculator shortcuts, right? So there's this thing about binomial, CDF, PDF, and blah, 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 P and C and all that crap. Yeah, just stop. No, stop it. So that's a great way to check your work, but you have to first have work before you can check it, right? So your calculator could certainly pass this class and go on to have a nice life, and then you're retaking it. So let's not do that. You have to use the formula that we spend a lot of time creating, this little dude here. Now, unfortunately, these problems are not one step and you're done, except for the very first one about deaf babies. I know that's a great way to start a homework set, is to talk about deaf babies, but oh well, that's how we started. But this one says at least 8. What does that mean? At least 8.
1 through 8?
No.
No? Okay, yeah.
That would be sort of less than 8, except for you left 0 out.
Starting at 8.
Yes, so at least means starting at.
Okay.
At most means going up to, right? If you have to be at least 40 inches to ride the ride, can the 38-inch kid ride the ride? No. Like the parents look at him like, maybe next year. Did that happen to Jeff? Yes, it happened to Jeff. I still remember. So at least 8 would be 8, 9, 10, 11. Is everybody with me? So you'd have to do the formula for 8, for 9, for 10, for 11, add them all up, right? Why does it make sense I'm going to add them all up? Because this is the probability of 8 or means add, 9 or 10 or 11. So what would it look like for this? What would the formula look like for 8? How many people do I have total?
11.
11. And I want to choose
8.
8 of them. So how many successes do I have?
0.30 and then 8.
Good. 8 of them. And how many failures do I have?
3.
Good, because I got 11 total people. So do that formula, do it for the 8 and do it for 9 and do it for 10 and do it for 11. And just to warn you guys, those will get very tiny. Those probabilities will get very tiny. Why does it make sense? If only 30% have adequate supplies, do you think it's very likely that all 11 will have supplies? No. That's going to be a small probability. How are we doing out there so far? So some of you guys are seeing questions like this, and you're only doing this. They didn't say exactly 8. They said at least 8, which is 8 or 9 or 10 or 11. I like it. Anybody not with me right now? You guys okay?
So then 11 would be 11, choose 11,
Yes.
3, 11, 7, 0.
Yeah, all 11 successes and no failures. Yeah. Yep. Right, because what's got to happen about each of these probabilities, when you add them up, you have to get what? When you add these exponents up, oh crap, what are you doing, Pen? I love it. Yeah, in this case, they have to add up to 11. In general, they have to add up to be n. They have to add up to be the total.
And you said that if it's 0, it equals 1. No, wait, was that something else? That was
You're
it.
thinking about when I was talking about like to the power of 0 and all that kind of stuff, and it was 1.
Was
But
it?
you don't have to remember that. You could just do the formula with a 0 in it. It'll still come out right.
Okay.
Yep. So let's look at a problem. All right, is that okay for that problem? Let's look at a more complicated problem. Let's see. So like number, what's a good one? Yeah, sure. Here we go, number 85. So somebody help me out. Let's get caught up with these problems. So from this situation, can somebody tell me what is n?
25.
Good, I got 25 people. What is p?
0.04.
Good, 0.04. And sometimes you get somebody tell me this is 0.06, but no, come on. What's q?
0.96.
0.96. 11. They got to make a full one together. Now, what is this question number 85 asking for? It's not asking for the probability of 4. Nope. What is it asking for? Yeah, somebody's got it in the chat, thankfully. Well, is everybody okay out there? So you guys, obviously it's not asking for the probability of exactly 4. So don't just do 4 in the formula and stop. What does at least 4 mean? At least means starting at, right? So what's at least 4 mean? Is this thing on?
4, 5.
25.
Yep, 4 or 5 or 6. Why am I making a big deal? Or means add. That's the most fundamental thing we learned from chapter 3. Or means add, and means multiply, basically, right? Or 7 or 8 or shiza. All right, so that would work. If you do the formula for each of those and add them all up, you would get the answer. Does anyone here want to do that? Would anyone rather not do all that much? We'd rather not do all that much, right? We're like, please, dear God, tell me. So I really, listen. This is a huge note. Whenever there's less work in the opposite situation, I'm going to do that shit. So I'm going to answer the opposite of what the question is. So the question gets angry and then I do 1 minus that, answer the question, right? If I can figure out the opposite probability, I do 1 minus that. You guys understand how do opposite probabilities interact? One is 1 minus the other one. So what is the opposite of this situation? What is it that this leaves out?
0, 1, 2, 3.
Yeah, 1 minus the probability of 0, 1, 2. Isn't that a lot less work to do? So if I figure out the probability of 0 up to 3, I can then do 1 minus that, and it would become the probability of at least 4. Yeah, Corbin's got it in the chat in a more concise way. I like it. Does that make, let me see. Does that not make sense to anybody? Because I want you to get this. I did this once before. What's the probability of 0 plus the probability of 1 plus probability of 2 plus probability of 3 plus the probability of 4? Okay, Jeff. Plus the probability of 25. What's that got to equal?
1.
1. Isn't this the question that's being asked? Right? At least 4? Isn't that the question? That's the question. Is everybody with me? So if I do 1 minus this, don't I get this? If I do 1 minus a piece of it, I get the other piece. So why would I ever want to do that? Well, because there's a lot less work for the opposite probability, right? That's anytime the opposite probability question has less work to do, I'm going to do that. And then I do 1 minus, done. I really want you guys to get that. What's a situation we've seen already that does this? It's an extreme situation. Probability of at least 1 is 1 minus the probability of none. That's the extreme. That's got one thing to do, right? So if this problem said the probability of at least 1, that would be 1 or 2 or 3 or 4 or 5 or 6 or 7, all the way up to freaking 25. Well, what's the opposite of that? None. I only have to do one formula. Of course I would do that. So this is more, but it's still a lot less than all this shit, right? Or stuff. I don't know where everybody's kids are. Sorry. Back in the day when I was in a classroom, I could just cuss willy-nilly. Now I got to be careful. All right. Anybody, is that better? Do you guys, I know some of you guys hate it because you're like, well, I could just do binomial PDF and get done with it, Jeff. And I'm like, that's too bad. That's your calculator doing this stuff. And then your calculator passes, like I said before, right? All right. Are there any other specific questions from 4.3 or anything actually from chapter 4 since the quiz is over chapter 4?
94 was kind of confusing. It was the dice one.
Yes. Good. Let me see. Hold on. Yes, Alfonso, you will. So 94. Yeah. All right. So one little thing about 94, you got to be careful about rounding too much. So one reason I say take probabilities to 4 decimal places is if you round it to 4 places, then you're not going to have as big of a rounding error. So some of you guys were telling me the probability of getting a 1. Well, let's do this methodically. What is n for 94?
6.
Good, because I have 6 dice. I'm going to roll 6 dice. So I'm going to roll a die 6 times, basically, right? So n is 6. What's p?
1/6.
1 out of 6. So here's where people were telling me this was 0.16. Is that true?
No.
All right, so that's false for a couple different reasons. A little better than 0.16 would be 0.17, because that's true. It would be 1666. So it's better to say 17, but it's 4 places, please. Or you could keep it as 1/6. That's actually even better because then it's not rounded at all. But if you want to put a decimal, do a 4-place decimal, 1667. So then what's Q? The guy that messed with the Enterprise. No. Where's my fellow geeks? Anybody? 8333, exactly. So just 1 minus what I've got already, 0.8333, because P and Q together have to make 1. Okay. So which part were you having trouble with?
It was part F.
Oh, You can't answer this question until you know the probability of 3 and the probability of 4. And then you can just see which one's got a higher probability.
Okay.
Yep. How would you do this one? What's the formula? Anytime they ask for the expected value or the average, what's the formula for the average for a binomial problem? Oh. Yeah. NP. It's the best formula yet, right? I don't have to make a table. I don't have to do any of that crap. I just say N times P and I'm done. All right. And this is where it's better to keep it as a fraction because, I mean, if you roll 6 dice and the probability you get a 1 is 1 out of 6, doesn't it make sense? How many dice would you expect to see a 1 on average? If it's a 1 out of 6 chance and you roll 6 dice, how many should you see a 1 on average?
1.
1. 1/6 of them. Right? Does that mean if I roll 6 dice, I will see exactly 1, 1? Hell no. But it means if I rolled 6 dice over and over and over, I would average 1, 1 for each roll. So I'd have to do it many times. Okay, I'll stop. Is this better for anybody? Are you guys doing better or?
How would you work through part E? Because I got a weird answer. I
Oh,
got, like,
so you want all 6 dice to show a 1, which means you want how many successes?
6.
6. There you go. So you have 6 dice and you want to choose 6 of them to succeed. So how many successes do you want? Oh, Jeff, too far, buddy. I just got too excited about. I'm a math teacher, so I had to put my evil 666 down there. All right. 1, 6, 6, 7. There you go, buddy. How many of these do I want?
6.
6.
I want 6 of these. So how many of these do I want?
0.
0. Become a 6. Become a 6. There we go. All right. There you go. Just throw that in there. You're done.
Okay.
That's awesome. There's only 1. All 6. Great. So it's not at least something. It's not at most something. It's just one thing I have to do. That's fantastic. Some of you guys did this even without all this whole formula. You could do it without the whole formula, but I'm not going to tell you. You just do the whole thing. You're fine. Okay. So 2 things to learn. Binomial CDF. I don't want to see that shit at all. You can do it. You can check your work. That's fantastic. But you can't check work that doesn't exist. So I need to see your work. And secondly, be really careful if it says at least or at most. That's going to be normally more than one thing that you have to do, right? Because at least and at most means more than one thing. Okay. Is that better for this section? Are you guys feeling better about that section? I haven't, wait, what section is this? 4.3? Yeah, I haven't finished grading all of 4.3 yet. I graded all the 4.2s. But, not surprisingly, I haven't graded, especially considering some of them came in 1 a.m. this morning or something. I haven't found time to grade those yet. Sure, of course, Corbin. Yeah. So like I said, at most means up to. At least means starting at. And I think about this. You can have at most 6 people on an elevator. You see that on a little plaque. So how many people can be in the elevator?
1, 2, 3, 4, 5, or 6.
Yeah, so at most 6 or none, and then the elevator is fine. That 7th person tries to come on, you're like, no. Well, especially nowadays, you're like, I want maybe 1 other person in the elevator with me at the moment, right? That 3rd person trying to, no. COVID, physical distance, get the hell away from me. All right. At least something like you have to be at least 40 inches tall to ride this ride. So you have to be 40 or more, right? So be careful what those phrases mean. Okay. Anything else from chapter 4 stuff before we get back into 5 and 6? Yes, yes. Somebody. Somebody has unmuted, but they're not saying it. Hello?
So can you do the 100D and F?
Okay, let me see. Yeah, isn't this the one we did? Let's see. Isn't that the first one we did? So at least 8.
Yeah.
Means 8 or 9 or 10 or 11, because in this case, 11 is the most I can have.
Okay.
You have to do the formula for each one of these and then add them up. And my warning was they get kind of tiny further up you go. Okay.
It's like a C stuff. Like 11C8 multiply.
Oh, yeah. So like for 8, it would be 11, choose 8. Is that what you're trying to say? And then 0.3 is the probability of success. So I want 8 of those. So how many failures do I need to have?
And add and like minus 1 minus
No,
like that.
I don't have to do 1 minus.
So
Really?
add all and after that like minus 1
that's it.
minus like
Do all of these and add them and you're done. Yeah, because this is the question, right? At least 8 is this. I didn't have to do the opposite because the opposite would actually have more work. What would the opposite of this work be? It would be 0 or 1 or 2 or 3 or 4 or 5 or 6. I don't want to do that. It's more work. So you only
okay.
do the 1 minus when the opposite situation has less work.
Okay. How about F?
Oh, expected value. What's the formula for the expected value? Otherwise known as the mean.
Is mean?
Yep. Expected value is the same as mean.
NP?
Good. So that's all you got to do.
Okay. Okay, thank you.
You're welcome. But don't feel bad. I mean, I understand the wording in the book is a little bit wonky sometimes.
Okay.
When you see expect, or obviously when you see average.
Okay.
Average, yeah. Okay.
Thanks.
You're welcome. Okay. Anything else, guys? All right. So let's get back. Let me turn off my Death Star. Doop. All right. Let me reorient to my room. All right. So last time we barely got into the idea of uniform distribution, and I want, all right. The uniform distribution is very simple. The most important thing to learn from it is that if I draw a given probability situation, if I can draw it and make the area 1, then the answer to any question will be the area related to that question. What the hell do I mean? Remember the thing about the dartboard? And the answer to the probability I hit a certain area on the dartboard was equal to the area of that section? No, you guys forgot that? It's been too long? Okay. I still need to get new markers. Dang it. All my markers are dying. All right. See who's going to work. Come on, blue. All right. Can you guys see everything? No. So if I could actually have, there could be a situation. We're not going to deal with these, but there could be a situation where a probability distribution is triangular. You could have a triangular probability situation. So it's like maybe from 1 to 7. And this gets really a lot more difficult. Why would this be more difficult? How tall would this have to be? Well, that becomes a very interesting question. So again, I'm not going to spend a lot of time on this, but I just want you guys to realize the bigger idea. So what would this mean? This would mean that it's very unlikely to be near to 1, and it's very unlikely to be near 7, but it's much more likely to be at the middle, right? 4 would be the most likely area to be in. So there are distributions that are sort of triangular shaped. So in order to answer a question of something like, what's the probability that it's between 3 and 6? So that would be this area, 3 and 6. I'd have to find this area. Okay. Now, real quick, stay with me. And again, I almost didn't want to do this example, but I obviously had decided to do it. This is much, much harder than a uniform distribution, because what's the area formula for a triangle?
Isn't it like BH 1/2?
Yes, 1/2 BH. Half height times base, half height base. Sorry. There was a time when I tried to make a song out of that, but it's old. What's the base of this triangle? It's 6. Is that cool? You guys with me? And what do I want what do I want the entire area to be? For any probability distribution I draw, what do I want the whole area to be?
1.
1, because that would represent every probability has to sum to be 1. So I know I want the area to be 1. I know the base is 6. So can you get the height?
Is it 1/7?
No? Oh, I see where you're getting that from, sort of, but
1/6.
no. What's half of 6?
3.
3. So then solve for h, I get h is 1/3. And again, just the last thing I want to say here is, how would I find this area? So do you see, I'd have to figure out the area of this weird shape. But if I could figure out the area of that shape, that would be the answer. Much harder than a uniform curve. Do you understand? Because look at this. What kind of shape is this? It's kind of a funky shape, right? So I sort of have, all right, I'm not going to look at it anymore. I'm not going to. It's actually a bunch of trapezoids. I'd have to figure out the areas. So thank God we're not doing triangular distributions, correct? So one reason I want to show you this is just to say, hey, look, aren't you happy we aren't doing this? Now, so let's go back to what we're actually doing. So I can have a uniform. Come on. Do I have any markers? I don't think I do. Uniform distribution. See if that works better. Let's just say it's from 5 to 17. Sure. From 5 to 17. All right. So that means it's going to look like this. 5, 17. And it's flat. That's what uniform means. It's uniformly distributed. Nobody gets more probability than anybody else. They all get the same amount. So it's equally likely to occur around 5 as it is to occur around 17 as it is to occur around anything in here. Let me ask you this question right now before I do anything else. Before I even do anything, what's the probability x equals 20? What's your gut tell you?
I don't see a 20.
Good.
0.
There. Yeah. Because what's the only thing? What is this setup that X has to be between 5 and 17, correct? So what's the probability I get a 20? No chance. Doesn't happen with this probability. I like it. Okay. Now, so that's a little side note. What's the height? Does somebody remember how to get the height of this? I want the whole area to be 1, right? So
Is
what's
it
that?
1/12?
Good. So this is 12 across. So this has got to be 1/12 to make an area of 1. So they have to tell me these. I draw the picture, I figure out the height, and now I'm ready to answer any question they ask. So let's ask a few questions. What's the probability? It's somewhere between 8 and 11. Can you draw that in here?
Yes.
Yes, you can. I have faith in you. So here's 8, here's 11. It doesn't even have to be a scale.
Wait, can you show how you found the height again?
Oh, I mean, well, this is 12. Is that cool?
Yeah.
And I know I want the area of this to be 1. 12 times what is 1? 12 times its reciprocal is 1. So the height will always be the reciprocal of the width because I always want them to multiply to be 1.
Got it.
Now watch, this is so beautiful. Now that I've got a probability distribution that's drawn and I've got the total area is 1, the answer to any question like that is equal to the area of that section. How wide is this rectangle?
3.
3. How tall is it?
1/12.
So what's the area of that? 3 times 1/12, 3/12, 1/4, 25%. That's it. That's it. So if you can draw the question in the picture, find its area, you are done. Next. Okay. So desperately want you to let uniform distributions be easy. All right. So let me ask you this. It's sort of related to this, but it's a little bit more difficult to understand. What's the probability that X equals 7? Let me take this off of here. Does anyone notice a problem with this? Let me put 7. Here's 7. 7.
Is it because there's like no distribution? Like there's no number to start and go to finish at?
So how wide is the line I just drew?
Nothing.
0. So the probability I get 7 is 0. Now, really quickly, I really want you guys to understand why that makes sense. Can somebody tell me how many numbers are between 5 and 17? Notice I said numbers. I didn't say whole numbers. I didn't say any. I just said numbers. How many numbers are between 5 and 17?
12.
No.
A lot.
A lot.
Yeah, be more specific. Do you mean like 400? Do you mean like 18 billion? There it is. I see it in the chat. There's an infinite number of numbers. Does anyone not believe me? I could have gone temporarily insane. Or I could just be insane all the time. I don't know. Does anyone not? It's okay if you don't believe me. Yeah, it's totally continuous. That's the big point I tried to make last time, right? That this is a continuous distribution. Because remember, what was it we dealt with last time? The amount of time it took me to find my keys. Time is continuous. I can measure it more and more and more precisely. So whatever this is, it has to be continuous. I like it. So here's the thing. Here's 5. What's the next number up from 5? 5.000. So I could do 5.1, but then I'm like, oh yeah, there's 5.01. Oh yeah, but there's 5.001. Oh yeah, but there's 5.0001. Oh yeah. How long could I do that for?
A long time.
A long time. Be more specific. Forever. For the rest of time, right? And I haven't even made it past like right here. I haven't. And so anyway, sorry. So doesn't it make sense that the probability of any one specific thing happening is basically impossible because it's 1 out of infinity? The probability of any specific number happening is 0 because it's 1 out of an infinite number of possibilities. How are we doing out there? Is that too far? I really want you guys to really, and what's the better way to say this without talking about infinity? The answer is equal to the area. And what's the area of a line? 0. So that's the quick way to think about it, right? I like it. Anthony gets it. All right. So what about this? Here's another question. Not quite as freaky, but still freaks people out sometimes. You can get rid of this. Go away. All right. Part C. Let me see if anybody's working better. What's the probability that I get something from 3 up to 6?
Would it be 25% again?
No. What's different about this one? 8 to 11 was totally inside. What's different?
0.
Oh, you're right.
It's not 0. Can you shade in the area that this correlates to?
Would it be like 1 because 5 to 6 isn't?
There we go. This is the only part of that that matters. Couldn't I ask you, for example, couldn't I ask you this? Roll a normal die. What's the probability you get at least a 6? What's probably get a 6 or a 7 or an 8 or a 9 or a 10? That would be 1 out of 6. Right? Because you could get a 6. The 7, 8, 9, 10 shit doesn't even come to play. Those are all 0 probability. Right? I'm talking about normal die, not like a D&D die. Not like a 20-sided die. Get out of here with that. So 3 to 6, people suddenly create, say it's 3 out of 12. No. The only part of that that has any area is this one. So that'll be 1 out of 12, which is 8.33 whatever percent. I think, if I remember right.
So if it was 3 to 7, then it would be 2 out of 12 because we're only counting what's inside from 5 to 17.
3 to 7, I can translate that to 5 to 7. So instead of starting at 3, I start at where it first starts to exist. So this just becomes 5 to 6 because that's the only part that has any chance to happen. Yeah, I like it. That's pretty much it for weird questions. Here's one that shouldn't be too weird. This one should be easier. What's the probability x is greater than 17? All right.
Would it be 0?
0, of course, because it's impossible to be above 17. Given that this is uniform between 5 and 17, that's impossible. I like it. So, all right, good. We're not going to focus too much on this problem, but it lays the groundwork for this very important idea. If I draw any probability distribution so that its area is 1, whatever the shape is, maybe even this shape here, maybe even this shape here, I don't know. If I draw it and I make the area 1, any probability question is then just finding the area of that question. It's such a beautiful, why is this easy? Because the area of questions are rectangles. Yay. right? What about this? This we're going to need some help with, right? If I do an area of this, it's not anything. It's got a wonky side. It's got a curvy side. Oh, shite. So we're going to need some help. So we're working up towards that. Okay. One last thing about these guys. Let me get your gut reaction to this. What would your guess be for the average of this distribution? Oops. What would your guess be for the average? No? So let's say this is ages of kids, 5 to 17. What would the average age be? Where would the average age be in the distribution? Would it be here?
In the middle.
Right in the middle. So how do you find right in the middle? What do you do?
Add them and then divide it by 12. Wait, yeah,
No.
2.
2.
So in this case, the mean would be 11. Is that cool? So in general, we call the lower number A and we call the upper number B for uniform distribution. So what's the general formula for the mean? It would be A plus B divided by 2. Now get ready. Standard deviation. I want to see how you react to this. And these are not big. There's a couple of homework problems about these. I'm actually never going to ask you these questions on the test unless it's a bonus question. That doesn't mean you don't have to worry about it. It's in the homework. You just have to throw shit into this though, right? So here's the standard deviation. You ready? Standard deviation is equal to the square root of b minus a squared divided by, of course, 12. You write that better. What's your first reaction to that? I might have emphasized it a certain way. That's the formula for the standard deviation. It is. Not bad. Oh, okay. All right. Normally, people's reaction is, why 12? But, if you don't have that reaction, that's fine. I'm not going to worry about it. Okay.
Is it always 12?
Always.
Oh. Yeah, why?
I love it. There's a question. So the answer depends on calculus. I do have a write-up of the proof of that.
Never mind, it's okay.
Okay. So if you're curious, I could send it to you. I know there's a couple people in here that have had calculus. But if you don't care, sorry, at least you know it comes from somewhere. It has a definite place of origin. So I could show you the proof of it. But that's what I would react to is, why 12? What the hell is 12 got to do with it? Okay. And by the way, it's not 12. I'm sorry. This is a total coincidence. It's not 12 because this is 12. Please understand. I could have picked anything. Of course, I picked something that had a 12. Damn it. It's always 12. Yeah, always 12. Okay. So that's it for uniform distributions. Okay. So the big thing to get from this chapter is that if I draw the probability distribution and I make the whole area 1, any probability question equals the area related to that question. Okay. So now we move into chapter 6, where we talk about normal distributions. Oh my gosh. Of course, my markers are dying the week that I'm boycotting Amazon. All right. Normal distribution. Oh, wait, I got a marker over there. Let's see if he works. Come here. He's red. Ooh, excuse me. All right. Do you guys remember anything about normal distributions? So that's what it looks like. Can somebody tell me anything you remember about these? We've worked with these a little bit.
There's percentiles.
Okay,
Three
okay.
percentiles.
Yeah. So if I go one step up and one standard deviation up, one standard deviation down, what percentage does that capture? Do you guys remember?
Isn't it like 63?
Close.
68.
And if I go two steps up and two steps down, I'll capture anybody?
95.
95, good. And that is why. Remember where does unusual start? Who remembers this? Where does unusual start? How far do I go before unusual starts?
Outside the bell curve.
2 standard
Two
deviations.
standard deviations. So why does that make sense? Because if it's a normal curve, what percentage of the data is out there? There's 95% in here. So how much is outside?
5.
5%. And wouldn't you agree that 5% is a reasonable probability to start saying, well, that's unlikely. That would be unusual. If there's a 5% chance of something happening and it happens, you would go, well, that was unexpected. That's unusual. Yeah, there's only a 5% chance of happening. So remember, that's how we got min and max usual value. That's how we figure out where the unusual stuff starts. Okay. Now, this will help us accept something. So let's do this. So let me make this active on our canvas. Where's my canvas? Here it is. All right, let's see. Where are you? Here you are. Bam, bams. No, now, if you go to Canvas right now, let me show you. You should be able to see chapter 6, a module for unit 6, right down here. And you see this z-scores, because isn't it all about the z-scores that tell me how the probabilities, how the percentages are kind of distributed, right? How many steps I take. So let's take a look at this weird thing. Uh-oh. All right. So do you guys have this? Are you able to get this on Canvas and pull this up? I'm going to stop sharing here in a minute. Here we go. You ready? Does everybody... Yes, yes. Okay, here we go. See if anybody yells at me. Somebody help me out. Now let's see if we all, first, don't worry. We're going to go over how to read this chart. But I want to get something up here to compare to first. Can somebody tell me what percentage of the data is, let's say, below -1? Right? What percentage of the data is below -1? Can somebody figure that out?
16%.
Yes. So somebody was really surprised. So there's 68% in here. 32% must be outside. So 16% must be here. Does everybody see that? Okay, now hold on to that thought. Hold on to that thought. Let me see. Sorry, I won't sing again. I'm sorry. The way to read this chart, look what this picture is trying to tell you. This picture tells you several things. What is the only distribution that this chart works for? Does it work for a uniform distribution? Yeah, it only works for a normal distribution, right? Doesn't work for any other distribution. Any z-score that I look up, the chart will give me the area below that z-score. So to double check the 16% we just got, don't I want to look up the z-score of -1? Any z-score I look up, it will give me the area below that z-score. We already know the area below -1 z-score should be 16%. Are you guys with me? Nobody complained about what happened up here. So you all should be with me.
I don't understand how you got 16%. I'm
Oh, all right. So this is where I need everybody with me. So do you see how there's, let me see if I could be, I had a teacher that would teach like this. He would write over his head on the, and then you do it. Sorry. So I got 68% in the middle here, right?
Yes.
Which means how much is outside of there? How much is outside total? If there's 68% in the house,
Yeah.
how much is outside the house?
32%.
32%. So how much is on that side?
Oh, you mean total 32?
Total of 32 outside on both sides. So how much is on that side? Why do I cut it in half? Because normal curves are symmetric,
Okay, got it.
right, to the mean. Okay, okay. I love it. So I need everybody to understand where that came from. What sucks about this is I only can handle 0, 1, 2, 3. I can only handle those for this empirical rule. What if my z-score was 1.71? Could I be more precise with this? No. But now we can be as precise as we need to be. So let's see how to read this. Stay with me now. If I want to look up -1.00, and do you see, here's how this works. This is the first decimal place, and then you read over to get the second decimal place. So I want -1.00. -1.00 is right here.
That's almost 16.
Yeah. So the empirical rule just kind of rounds them to whole numbers. This chart is like the empirical rule on steroids. It shows me everything, right? And now do you see why I wanted to make you guys do probabilities to 4 places? One reason was to have less rounding errors, but another one was to get us ready for this chart. All of the probabilities are to 4 places. All right, so let's try. Any questions from what we just did? Did everybody understand the point that was just made? We knew the answer was 16% before we looked at this chart because we already had empirical rule, which is what this normal curve uses, empirical rule. But this is like all the little things in the middle, you know, it fills in all the little things in the middle. All right, so let me see. Let me try to build a problem. Yeah, I can write on this. Here we go. Let's try it, Jeff. So excited. So how would I do this? How would I figure out the probability that a z-score is less than, what do you got, Jeff? Sure, we'll do -2.43. You guys draw that. What goes in the middle for z-scores?
0.
0, good, because the middle of the picture is the mean. And for z-scores, the mean always becomes 0 because it's 0 away from itself. So where's -2.43? To the left or to the right of 0?
The left.
You wouldn't, you might not believe that people will put it over here somewhere. That doesn't make any damn sense, right? So negative 2.43 should be down here somewhere. All right. Does anyone have any trouble with what's happened so far? So just like we did on the board we did probability z less than -1. We did that on the board. Now I'm doing something more complicated because we have all the answers here. So what area, can you shade in the area that this problem is talking about? Sort of like we did with uniform curve where I shaded it in. What area is this talking about? Where would I shade? Which way would I shade? To the left or to the right?
To the left?
Yeah, to the left. Because I want less than negative 243. So I want this area. So how do I find that on the chart? Oops, sorry.
So the sign would like indicate where you're gonna shade what side, correct?
Yes, the inequality symbol is actually an arrow.
Hmm.
As long as the variable is on, oh shoot, I lost my, as long as the variable is on this side, this is an arrow pointing you in the direction to shade. Does that, you guys remember that from like inequality when you had to draw it on the number line? The inequality symbol was an arrow. It points you in the direction to shade, right? Now, don't you already see the answer is less than 50%? Would you agree with me? Isn't this definitely less than 50% of the picture? Hell yeah. In fact, it's less than like 10%. I mean, it should be a pretty small answer. So how do I look that up in the chart? All right, well, let's see. I know the first decimal place is negative 2.4. Negative 2.4. Right? So I know I'm going to be in this row. And the second decimal place is 3. So negative 2.43.
So technically 1%.
Yeah, just under 1%. I like it.
Yeah.
So I would put that up here. So areas go up here. Z-scores go down here. All right. Now, if you're in Canvas, you should notice there's a negative Z-score, and if you scroll down, there's a positive Z-score, right? Which kind of makes sense. So I'm going to erase this. Has everybody got this here? I do have a handout that we'll kind of get started here in a minute, but I want to do a few of these together with you. So everybody got this? I'm going to erase it. You ready? Okay. Oh, wait, somebody's chatting at me. Oh, all right. So to look up any Z-score, negative 2.4, that's the first decimal places, right? Negative 2.4. So I'm in this row. And then I go over to where it says 3. So this up here is the second decimal place. And these go up to the first decimal place. So I kind of take 2.43 and I break it up into 2.43. So that's the area right there. So if you did a test and your Z-score for your test was negative 2.43 and the grades were normally distributed, that would mean that 0.75% of students scored less than you. So that would mean bad things, right? Okay. Any other questions before I delete this? Okay. I don't see anything. Here it goes. Bye. All right, let's try a more complicated. Let's come down here just so I can show you the positive Z-scores. So here's the positive Z-scores. Why does that look so much worse? I don't know. Sorry. Got a little freaky. I think you can still read it. Okay. So let's try a problem out here. Let's see. Something I can keep on the screen. Okay, good. This will work. Let me try something else a little different. I want to know the probability that z is greater than 0.76. I like it. Can you draw that first? And of course, I got to tell you, I'm working with a normal curve. I'm working with a normal curve. What's the probability z greater than 0.76? All right, so in the middle, for z-scores, you always put 0 in the middle. That's what the mean would become. And of course, where's 0.76?
On the right side.
Good. And it's not too far up from 0, right? So maybe right there for 0.76. And I want, where's the area? Which way do I shade?
Right.
Yeah, greater than, so I want this. Now, what's wrong with that, considering what the chart tells me? What area does the chart always give me for whatever z-score I look up? It gives me the area that is
To the left.
yeah, so somebody in the chat said that. Yes, the area to the left, the area below what you're looking up. But what does my problem want? My problem wants the area above it, right? All right, so that's not that big of a deal. What do you get when you look up 0.76? What area do you get when you look up 0.76?
0.7764.
That's neato, right? So how did you get that? So you got 0.7, so we're right here. And then you got to all go way over here to 6.76. 0.76. Does everybody see how to read this table? So 7764, that's neat. Where does that go on my picture? Uh-oh. Where does that go on my picture? What's that the area of? Is that my answer? What's 7764 the area of? I don't know what that means on top. It's the area of all this. So how do I get my answer?
You subtract it
From-
from 1.
Yes, kick ass. Look at this. You've been getting ready for this day for a while. So if I know the opposite, see how I figured out the opposite of what the question wants? So how do I get the answer? 1 minus that. Here, real quick way to do 1 minus something. I know you got a calculator. I don't care. What makes this 9? 2. What makes this 9? 2. What makes this 9? 3. What makes the last one 10? 6. Okay. I understand. How's everybody doing out there? Of course, you could just throw this in the calculator if you don't want to do the thing the guy just did.
So if we shade on the problem, okay, we shade to the right, but z-square, you shade to the left. That's how we know we're supposed to subtract it from 1 or
Yeah,
1.
you shade the area for the question.
Yes.
And anything you get from the chart automatically goes below what you looked up. So then you say, oh, I don't have the answer yet because my answer is this. So I want the graph to help you, right? To put things in the right place, to know if you don't have the answer yet. Does that make sense? And here's something else. Let's see how many people understand this. You don't have to do this. This is a little tiny shortcut. Can you please, on the negative chart, please look up negative 0.76. What do you get?
The answer that we just got.
Yeah, we get 0.2236. That's the answer we got. What the shit? What? Well, here, let me explain that. See if I can put this in the right place. No, you can't, Jeff. You suck. There. Well, almost. All right. Jeff, it doesn't matter. Okay. I really want this to make sense. All right, let me see. And this is a little tiny nothing shortcut, so I'm not going to spend a lot of time on this. But the area that is above 0.76, because of symmetry, doesn't that have to equal the area below negative 0.76? Don't they have to be equal? Because it's symmetric to the middle, right? So this area here has to be the same as this area here. It is not important if you don't quite get that, because we didn't need the shortcut to do the problem. We did the problem, and then I told you about the shortcut, didn't I? So it's just a shortcut. If you don't get it, don't worry about it. But it's because of the symmetry. The area above positive 0.76 must be equal to the area below negative 0.76 because of symmetry. It's perfectly symmetric around the middle line. Do you ever have to do that? Nope. It's just a shortcut. If you get it, use it. If you don't get it, never use it. All right, let's try one more problem. Then I'll show you the worksheet. And then we're actually got to leave early today because I got a 3 o'clock meeting. I know. You're all bummed out. I know. All right, so I'm going to clear this away. Is everybody ready? We're going to do one more problem. I'll show you the worksheet and then we'll call it a day.
Wait, can you explain one more time why it's 1 minus 0.7764?
Oh, yeah. Do you agree with that the question wants this area here, right?
Right.
When we look up anything in the chart, it tells me the area below what I looked up.
Oh, okay. Uh-huh.
And the whole picture has to have an area of what?
1.
1. Good.
Got it.
So if I know this chunk is 764, the other chunk must be 1 minus that.
Got it. Thank you.
So
Now,
for z-score, it's always like the score is always the area that's shaded to the left, because I'm looking up at the hill and everything to the left is blue, even on the negative one.
hold on. Yes, this chart always tells me the area below
Okay.
the score I looked up. It's a very single-minded chart.
Okay.
So if my question wants above, I have to adjust what this tells me.
Okay.
I like it. All right, so now I'm going to delete this. I forgot how to. There it is. Okay. So let's do one more problem up here. Sure, we'll stay here. So I want to know the probability that a z-score is between 0.13 and 2.25. Oh, shit. So this should feel very familiar. It's just like a uniform probability question, right? You draw in, you shade in the area. So let's draw the picture. There's a 0 in the middle. Right? Where is 0.13? It's going to be a little bit where?
The positive side of the 0.
It's a little bit to this side of 0. There's 0.13. And then where's 2.25? It's going to be a lot more out there. So where's the area this wants?
Between 0.13 and 2.25.
Yeah. And does this chart have any clue how to get that area to me directly? No. This chart is dumb. This chart only understands areas below a z-score. Now listen, I really want you to get what we're about to do. If I look up 2.25, can you guys look up 2.25 for me and tell me the area? Of course, it would be this whole area, right? When I look anything up in the chart, it tells me the area below that thing. All right, somebody's got the answer for me. Do you guys agree? 225. Be really careful. 9878. I like it. So be careful because sometimes, do you notice how if I want to get to 5, this is 0, right? 2, 2, 0, 1, 2, 3, 4, 5. Sometimes people make a mistake because they count this as 1, but it's 0, of course, right? So just be careful about that. So this will be 9878. Is that too much or too little? Is that more than the answer or less than the answer that I need?
Less.
Too much.
That's way too much, right? I just want this area. And I went all the way. So where am I supposed to stop? I don't want to go all the way. I'm supposed to stop right here, right? So if you look up 0.13, isn't that exactly how much area that this is too much? I don't know if that makes sense. This area is way too much because I want to stop here. If I look up 0.13, that's exactly the amount of area that I want to subtract off.
0.9032.
Somebody tells me it makes sense. Thank God. So 0.9, let's see. You guys agree? I haven't even looked it up yet. 0.90, what'd you get again?
32.
No, be careful. I think you're looking at, what are you looking at? Let's see.
Oh, I'm looking at
Oh, you're looking at 1.3.
0.557.
Do you see? And it's supposed to be 0.13, right? 0.13. So we want 0.1.
5517.
Yeah, 5517. I like it. Is that what somebody chatted to me? I don't know.
Yep.
Many chattings. Okay, there we go. Oh, somebody's way ahead. So now I really want this to make complete physical sense. This is obviously too much because it goes all the freaking way. So if I just cut off this much, it'll be the exact right amount. So take 9878 minus 5517. There's no shortcut for this, really. I get 4. What is this? 3, 6, 1, I think.
Yes.
Yay. All right, now this, to me, this is different, but it's built on something we talked about a long time ago, the empirical rule. And it isn't difficult, it's just different. It's built on the idea of uniform distributions where the area is equal to the probability. It's built on empirical rule. It's built on a lot of different things. All right, so let me clear this and I want to show you the what do you call it? The handout that we'll probably work on next time. Let's see. I need to unlock it, I think. Let me leave student view and I'll become like a god. Let's see here. Modules. All right, let me unlock it. Where are you? Guten Lorden. Here we go. Normal distribution practice. So it should be unlocked. And see a lot of questions like the ones we just did together, right? And then down here, they get freakier and freakier and freakier. Do you guys remember the z-score formula? Anybody? How do I change like an X score when I know the mean and the standard deviation? How do I change that into a z-score?
Don't you just add them up and then divide it by 2?
Definitely not.
Oh,
What does a z-score tell you? It tells you the number of, does anyone remember? All right, here we go. This is a major note to take because I will ask you this question on several of the remaining graded assignments. The z-score tells you the number of standard deviations from the mean to the data point. Does that sound familiar? I mean, a z-score is what we use to measure how far something is away from something else, from the mean specifically. So the z-score will be the data point minus the mean divided by standard deviation. So I see how many steps fit in between, how far apart they are. So this problem doesn't start off with z-scores. It starts off with what's called raw scores, like unprocessed scores. So how do I change 27.2 minutes into a z-score? Well, I do 27.2 minus the mean divided by the standard deviation. Oh, crappity do that. And before I finish that out, so in the middle would go the mean. And then my 27.2 is right there, somewhere over here. And I want less than that. So that would be where I shaded it. Okay, sorry. So this is a lot to kind of take in. I just wanted to try to throw this at you a little bit now. We'll do this whole thing, of course, next time. But if they don't give me z-scores, I can make what I'm given into z-scores if I know the mean and the standard deviation. Right, so it's whatever the hell that is, and then I can just look that z-score up in the chart and get the answer, and I'm done. So if they aren't z-scores to begin with, they are very easy to make into z-scores. I just have to use the z-score formula. Crazy enough. All right. I think that's enough. Let's see what time is it. Yeah, this will be fine. This will be the earliest we've left, I think, but I want to have a little bit of time to get ready for this crazy meeting. Yeah, that's good. So we'll obviously do more. I didn't mean for this to be a all-encompassing lecture here. So we're going to do more of this next time. But just to show you where we're headed. Didn't get cut off. Oh, good. Okay. All right. So that's enough, guys.
I have 6.
The quiz is going to unlock at 3. Does anyone want to start it before that? I could unlock it earlier. No? Okay. Oh, there is, I got to do this right now before I forget. I'm going to send out invitation to a Zoom study session tonight, and it will start off without me. Starts at 6 o'clock tonight. So look in your Canvas email for a Zoom invitation to a study session tonight. I'm going to stop in after my last class. Should be around sometime before 7, 6:45, something around there. Just to see how everybody's doing. And yeah, so you can go there if you want to. Please, again, I will know who goes, and I will know if you're taking the quiz while you're there. So don't pull that shit, right? I'll say, I could do the quiz and come there and get help with the quiz for people. Yes, no, you can't. You better not. That's a bad idea. And how long this session lasts is up to the people that are there. It's not, I'm not controlling it. So it's up to the people that are there. Yeah. All right. So just look out for, I'll send it right now before my meeting starts, or I'll forget all about it. Okay.
Thank you.
Thank you.
Let me know if you have any questions. Otherwise, I'll see y'all sometime.
Thank you. Have a good meeting.
Oh, thank you so much. We'll see. Oh. Some of these are crazy.
I have a question.
Yes.
When is the due dates for chapter 5 homework gonna be posted?
Oh, let me see. I guess I haven't done that yet.
Yeah, like I tried checking like last night to see when like they were due, but
Yeah.
it wasn't there.
All right, I'll put them up after I get this study session stuff sent out.
Okay, cool. Thank you.
Thank you. All right, here it is. Everybody good? I'm gonna head out. All right, I'll see y'all later.